Now, if you look in here, you can see like on the voltage subdivisions, we got time subdivision. There's actually 10 of them. So if you do the math, how much would each subdivision be worth?
1 volt.
No, it's in milliseconds.
100 milliseconds.
100 milliseconds, exactly. Each subdivision would be 100 milliseconds. Because 100 milliseconds times 10 of these subdivisions.
If you have it set on 1 second.
Exactly. Yes, exactly.
Depends on what you got it set on.
Exactly. I'm using this one as an example down here. You're exactly right.
In between them is 0.5, right?
Point 0.5. What's 0.5?
In between each increment.
No. Each one's 100 milliseconds. 0.1. There's 10 of them.
But in the middle of 1 point.
Yeah. So yeah, that's true.
It says, why did we start using elapscopes to aid in diagnosing vehicles? As the onboard processor speed increases, the length of time a glitch needs to occur for the computer to react has decreased. In the 80s and early 90s, a 500 millisecond glitch may not have affected drivability at all. Today, a 500 microsecond glitch can affect the drivability of a vehicle. And it must be on the CAN vehicle, on the CAN car. So remember, the lab scope takes samples of the voltage and draws a trace across the screen. A voltmeter doesn't have that capability. So if there's a glitch in between that trace, a good lab scope hopefully can pick it up and catch it. His Ford E4 controller does approximately 625 calculations per second. Ford's E5 controller does approximately 1.5 million calculations per second. Today's new CAN systems do several million calculations per second. How does this affect the tools needed to diagnose the vehicle? How does this affect the tools we need to diagnose the vehicle?
They have to be super fast.
Really fast. And here's the thing. Some people ask you, what's the difference between a scan tool and a lab scope?
Speed.
Speed is one. And a scan tool just tell you the area that's having a problem. It don't tell you what the problem is. A lab scope can pinpoint the problem to you. That makes sense? It's like,
You know how to use it.
yeah. A scan tool tell you the problem's in this area. You take your voltmeters, or now lab scope, and go to that area of concern and try to find the broken part or diagnose the broken component. So I know a lot of people, like you said earlier, like using a voltmeter because it's much easier and much quicker. But they want y'all to start using lab scopes. And so it's a hell of a learning curve. It's a hell of a learning curve, but if you can
Yeah,
use
not really a curve at all.
what is it?
It's like getting in a rocket ship.
If you had to get one to start off with, I would say get the Vantage Pro because it tells you how to hook. Well, I guess there's other ones out there also. I use the Pico, right? But I also use the Vantage Pro because it tells you how to hook it up to it and tell you where it's connected to. The Pico doesn't do that, right?
Well, that's the one made by Snap-on.
Yeah.
Is that
I
one still available yet? The Advantage?
yeah, the Pro Advantage Pro is.
Oh, okay.
At least I think it is. Uh,
I think they were
but I'm
coming
pretty.
out for
I'm
a while.
pretty. There may be other companies that do the same thing, but the only one I know so far is the Advantage Pro.
But that Vantage Pro, isn't that kind of an old one already?
That's
Yeah,
a
I know. That's what I'm
yeah.
saying.
Outdated?
It's not outdated. Well,
No.
it's an older one, yeah.
I
But
mean, the original Vantage has such a little tiny screen.
yeah,
And
that's the original one. Yeah,
yeah.
yeah.
Okay.
The reason I say about the Vantage Pro because if you don't know how to hook it up, the Lasco's no good to you. The Vantage Pro tells you how to hook it up.
Yeah. It's got a
That,
lot of good
yeah, it
information.
has a lot of good
Yeah.
information in it.
Uh-huh.
I used to use my fluke, and when the guy used to work next to me, he had the Vantage, the small screen that Kermit just talked about. I used to hate looking at that thing. But when I used my Fluke 88, that's the first one I had, my Fluke 88, I didn't know how to hook it up. So I used his Vantage to
That's
show
what
me
they
how to
make
hook it
YouTube
up.
for.
Huh?
That's what they make YouTube for. They'll tell you how
Oh,
to hook it up.
hey, back then it wasn't YouTube, dude. This 30 years ago. What are you talking about,
Yeah.
YouTube?
Yeah, exactly.
Yeah, it was no
You
YouTube.
know that me and Nate here, we used to work together at Tune-Up Masters about 35 years ago.
Yeah. I was thinking about you the other day, Kermit, because somebody asked me, I think a high school student asked me, he said it's $15 an hour or $12, $15 an hour, a good wage starting off. I said, are you kidding me? You know what I make starting off at Tuna Masters? I can't remember that number. I know it's minimum wage.
Yeah.
I forgot what that number was. It was minimum wage. And it
We
wasn't
were
$15 an
breaking
hour.
our butts.
Say it again?
We were breaking our butts too.
Yeah, and it wasn't no damn $15 an hour either.
No,
I remember working at
managers weren't even making that.
Yeah.
when you guys were working at Tune Up Masters. I was working at Arco MP&G.
Hey, I remember that, yeah.
The competitors.
Yeah, exactly.
So what's a good starting wage for today?
Hey Greg, I just sent it to you. Your ID and your
Okay.
PIN.
What is a good starting wage for today?
It depends what you're doing. If you're,
$20 an hour at least.
yeah. If you're,
Just to prepare.
if
I
you,
make $20 an hour.
yeah, I go with that. $18 to $22 an hour. I usually tell people. Cause $15 an hour, that's McDonald's money, right? Or fast food. They make a fast food now.
I hear that's what EMTs make.
Isn't that what the minimum wage is now? 15?
Yeah, that's what I said. That's minimum wage money right now. Yeah.
Yeah.
I think ambulance drivers only make like $16 an hour or something.
Oh, that's crazy.
That's terrible.
It is.
What's wrong? See coyote? See a coyote out there? All right, digital multimeters and intermediate problems. All right, so it says here, a digital multimeter was not showing enough information about a computer control circuits. On a newer system, the speed at which the systems are checked, sample time, has greatly increased. This created a new challenge in finding intermediate glitches. Now, here's an example I can think of. I had a Ford one time that had a hesitation and had a code for low TPS voltage. But when I checked it with the voltmeter, it was perfect. I checked it many times, and every time it was perfect. But as soon as I put a lab scope on it, right, it did this from a low voltage and start doing this. And came down. You probably can't see this.
Yeah, I can.
What were you checking?
A TPS.
A TPS?
Let me rewrite this. I'm gonna do it again. And from here, it would do this. Right off idle, then it got good and came back down. It was perfect. Right? The voltmeter wasn't fast enough to catch this.
So it was a stumble.
It's a stumble.
Yeah.
And every time I used the voltmeter, it was perfect. But as soon as I put a lab scope on it, it has to draw this out when the voltmeter takes the average.
Right.
So every time it glitched, it went down and drew it out. And you seen this dropout. That's the advantage of a lab scope versus the voltmeter.